lesson, we will discuss the controls and displays. There are two keyboard and cursor control units on the pedestal, one for the captain and one for the first officer. The flight crew uses the keyboard and cursor control units to display the flight management system pages on the MFD, enter and modify data on the MFD flight management system pages, and perform some flight plan revisions on the ND. In addition to interfacing with the MFD flight management system pages, the two identical keyboard and cursor control units interface with the NDs, the Onboard Information System, OIS, and the mailbox. Keyboard and cursor control unit controls for the flight management system are a keyboard which enables the flight crew to enter alphanumeric information, a cursor control device, CCD, which enables the flight crew to control the associated cursor, the flight management system shortcut keys, the clear information key, the ND and MFD keys, and the navigation keys. The keyboard and the cursor control device are independent of each other, and the failure of one does not affect the other. The flight crew can use the keyboard and cursor control unit to interact with the objects on different display units. In order to select flight management system pages on the MFD, the captain or first officer presses the MFD key on the keyboard and cursor control unit. From there, the flight crew can navigate through all the flight management system pages using the keyboard and cursor control unit. When the cursor is moved over an interactive element of the display unit, such as the aircraft status on the Flight Management System Active Initialization page, a light blue box appears around this element. When pressed, the following Flight Management System shortcut keys on the keyboard and cursor control unit allow the flight crew to have quick access to frequented Flight Management System pages and moves the cursor back to the MFD if the cursor was previously on another display. The Direct key displays the Flight Management System Direct To page on the MFD. The Performance key displays the Flight Management System Active Performance page. The A350 incorporates an Airport Navigation Function, ANF, that helps the crew navigate the airport environment while on the ground. The aircraft has two independent ANFs, one for the captain's side, one for the first officer side. Each ND displays the airport moving map when the range selector of the EFIS control panel is set to the zoom position. The flight crew uses the KCCU to activate the interactive functions of the ND. In normal operation, the ANF on the captain's side uses data from ADIRS 1 and Flight Management System 1, and the ANF on the first officer side uses data from the ADIRS 2 and Flight Management System 2. The aircraft has two ANF databases. An ANF database is loaded in both captain and first officer outer display units, which computes the ANF that appears on the applicable ND. The captain, first officer, outer display unit cannot display the ANF. The validity period and the part number of each ANF database are displayed on the status panel of the ANF on the ND. Each ANF uses the on-side ADIRS data in order to display the aircraft position on the ANF airport moving map. The moving airport map can be displayed on the ND when the position of the ND mode selector is plan, arc, or rose nav. In the zoom position, the airport moving map is displayed on the ND with a 5 nautical mile range or below. At landing, the ND automatically displays the ANF in arc mode with a 2 nautical mile range. The ANF provides the flight crew with a multitude of advisories, including a runway approaching advisory. During taxi, the runway approaching advisory warns the flight crew that the aircraft is near a runway or a runway intersection. The runway approaching advisory is only active on ground when the ground speed is below 40 knots for more than 10 seconds. The ANF uses the aircraft position, ground speed, and its database to trigger a warning at least 7 seconds prior to the aircraft entering a runway area. The ANF displays the indications of the runway approaching advisory on both the navigation display and primary flight display. In ARC and ROSNAV modes, when the aircraft approaches one or two runways, the ANF advises the crew. The runway that the aircraft approaches turns yellow and pulses, and a runway ident box that indicates which runways. If the runway is in the flight plan, it will be indicted with a green triangle and green font in the ident box. The various versions of the runway ident box are shown here. If the ND is not in zoom mode or is in plan mode when the aircraft approaches a runway, the runway ahead change mode message is displayed to alert the crew to change of the ND mode to ARC or ROSNAV in order to display the runway approaching advisory. The ANF no longer displays the runway approaching advisory when the aircraft stops, the aircraft is in the runway area for more than 2 seconds, the advisory is triggered for more than 30 seconds, or the ANF no longer expects that the aircraft will enter the runway area within the next 7 seconds. In this lesson, we will discuss the Flight Management System, FMS. Aircraft navigation is primarily accomplished through the Flight Management System, FMS. The Flight Management System provides flight planning and navigation information, performance calculation and optimization, and long-term guidance targets along the lateral and vertical paths. The Flight Management System also has an engine-out EO mode, a takeoff surveillance function, a time function, and a print function. Flight Management System information appears on the multifunction displays, MFDs, the navigation displays, NDs, and the primary flight displays, PFDs. The MFDs and the NDs are interactive displays that the flight crew uses to enter or modify data via the keyboard and cursor control units, KCCUs. There are two flight management systems. Flight Management System 1 is on the captain's side, and Flight Management System 2 is on the first officer's side. Each flight management system uses a computer referred to as the Flight Management Computer, FMC. The aircraft is equipped with 3 flight management computers. Flight Management Computer A provides data to Flight Management System 1. Flight Management Computer B provides data to Flight Management Systems 2. Flight Management Computer C serves as the backup flight management computer. Of the 2 active flight management computers, one flight management computer is referred to as the master and the other as the slave. Selection of the master flight management computer is based on which autopilot is engaged and the position of the flight management system selector. In normal operation, Flight Management System 1 and Flight Management System 2 operate in dual mode. The 2 active flight management computers independently calculate data and then share, compare, and synchronize the data. Each flight management computer has 4 databases. These are the Navigation Database, Performance Database, Magnetic Variation Database, and the Pilot Stored Elements Database. Some flight management system data can be customized by using the Airline Modifiable Information AMI file. The following controls and displays are used to interface with each flight management system. one MFD, one ND, one PFD, one Electronic Flight Instrument System (EFIS) control panel, and one Keyboard and Cursor Control Unit (KCCUs). The Flight Management System automatically tunes the nav aids that are used for the aircraft position computation, the nav aids for display on the ND, and the landing system. Nav aids displayed on the ND and the landing system can also be tuned manually on the Flight Management System Position Nav Aids page. Manual tuning of nav aids always has priority over automatic tuning. In the case of a triple flight management computer failure, the nav aids displayed on the ND and the landing system can be tuned manually via the radio management panel. In Flight Management System Dual and Independent modes, each Flight Management System tunes its on-site nav aids, including one VOR, 4 Distance Measuring Equipment DMEs, and one landing system. In this lesson, we will discuss the Global Navigation Satellite System, GNSS, and landing systems. Global Navigation Satellite System is a navigation system that uses satellite signals. Global Navigation Satellite System provides an independent source for position, speed, altitude, true track, and time data. The multi-mode receivers provide the Global Navigation Satellite System data to the Flight Management System via the ADIRS for display on the Flight Management System Position Monitor page and the Flight Management System Position Global Navigation Satellite System page. The FMS Landing System, FLS, enables the flight crew to perform non-precision approaches, including VOR, DME, non-directional beacon, locator, or radio navigation approaches in accordance with the Instrument Landing System Lookalike feature. For the FLS, the multi-mode receivers use the following: aircraft position from the ADIRS or the approach database from the Flight Management System. The FLS function is available only for approaches that are stored in the navigation database. The multi-mode receivers provide computed lateral deviation pseudo-localizer, computed vertical deviation pseudo-glide slope, and the horizontal distance between the aircraft and the anchor point of the FLS beam. The FLS beam appears as a magenta dashed line with a length of 80 nautical miles on the upper part of the ND and the vertical display. The FLS beam is defined by an anchor point, a course, and a slope. The flight crew can also use the FLS function to fly an instrument landing system approach with glide slope out, or a localizer only or localizer back course approach. The mixed localizer FLS landing system enables the flight crew to perform approaches with the localizer ground station only in accordance with the Instrument Landing System Lookalike feature. For the localizer FLS, the multi-mode receivers use the aircraft position from the ADIRS, signals from the localizer ground station, and the approach database from the Flight Management System. The multi-mode receivers provide radio lateral deviation from the localizer reference, computed vertical deviation pseudo-glide slope, and the identification of the localizer ground station. In this lesson, we will discuss the Air Data Inertial Reference System, ADIRS. The Air Data Inertial Reference System, ADIRS, is the main component of the navigation system, providing flight and navigation data. Flight data, such as air data, attitude, and velocities, ensure the control of the aircraft trajectory. Navigation data, such as latitude and longitude, heading, and time, determine the aircraft position and orientation. The ADIRS is comprised of 3 individual Air Data Inertial Reference Units, ADIRUs. Each ADIRU is made up of 2 parts. These are the Air Data Reference, ADR unit, and the Inertial Reference, IR unit. Both the Air Data Reference and the Inertial Reference can operate independently. The Air Data Reference Unit computes the air data parameters using data from different probes. One multifunction probe, MFP, per air data reference provides total pressure, total air temperature, and angle of attack measurements. One side slip angle, SSA probe, per air data reference provides the side slip angle. 2 static probes per air data reference provides static pressure. A 4th angle of attack, AOA probe, provides additional angle of attack measurements. 2 outside air temperature, OAT probes, provide static air temperature on the ground only. All the probes connected to the air data references are automatically heated to prevent ice formation, except for the outside air temperature probes. The Air Data Reference Unit provides the following air data: total pressure, static pressure, altitude, Mach number, computed airspeed, true airspeed, total air temperature, static air temperature, vertical speed, angle of attack, and side slip angle. The ADIRS data is displayed on the PFD, ND, Integrated Standby Instrument System, MFD, and the Permanent Data Display. The ADIRS has 3 fully independent sources of air data parameters. With the Integrated Standby Instrument System, which is independent from the ADIRS, the aircraft has 4 fully independent sources of air data. The Control and Display System, CDS, normally uses the ADIRS for display on the PFD, but in the event of loss of air data from ADIRS, the Control and Display System can also use the Integrated Standby Instrument System for display on the PFD. The inertial reference units provide the following inertial reference data: navigation information, attitude information, and heading information. Each inertial reference unit uses data from its internal gyrometer and accelerometer sensors. Each inertial reference unit also receives Global Navigation Satellite System GNSS data from both multi-mode receivers, MMRs, for initial alignment and for the computation of the Global Positioning and Inertial Reference System GPIRS position. The ADIRS is controlled using the overhead panel and the MFD. The ADIRS panel includes controls for both the inertial references and the air data references, consisting of an inertial reference mode selector for each inertial reference unit, an air data reference push button for each air data reference, an inertial reference push button for each inertial reference unit, and an on battery light. The controls are arranged in a 1-3-2 format, with ADIRU 3 acting as a backup for either ADIRU 1 or 2. The inertial reference mode selectors have 3 positions: off, navigation, and attitude. In the off position, the selected ADIRU is unpowered. Navigation is the normal mode of operation of the inertial references, and it provides navigation, attitude, and heading data. Attitude is the abnormal operation mode of the inertial references, and it provides only attitude and heading data. The attitude mode can be used in flight, and may provide a means of regaining some inertial reference data following a failure. During normal operations, the inertial reference push buttons are on with lights out. When an inertial reference push button is pressed, the inertial reference turns off and the off light is illuminated in the push button. An illuminated amber fault light in the inertial reference push button indicates that the inertial reference has failed. When the inertial reference fault push button is pressed, the inertial reference unit is turned off and the fault light goes out. All information about the aircraft position, navigation modes, position accuracy, navigation accuracy, and aircraft time reference is available on 6 specific position pages on the MFD. The flight crew can access these pages via the position menu on the general menu bar. Each ADIRS computes its own aircraft position and the associated position accuracy using 3 sources: the inertial references, the Global Navigation Satellite System, and radio nav aids including VOR, DME, and localizer. The aircraft position function of each ADIRS provides the aircraft systems with the most accurate position that is available using the following priority: the Consolidated Global Positioning and Inertial Reference System position, the ADIRS' own Global Positioning and Inertial Reference System position, the Inertial Reference Radio position provided by the Flight Management System, and the ADIRS' own Inertial Reference position. When the Global Navigation Satellite System data is available, each ADIRS uses the Global Navigation Satellite System and the inertial reference sources to compute a hybrid position referred to as the Global Positioning and Inertial Reference System position. When the Global Positioning and Inertial Reference System positions for the 3 ADIRS are available, the ADIRS compares the 3 Global Positioning and Inertial Reference System positions and selects the most accurate one to provide a consolidated Global Positioning and Inertial Reference System position. The Flight Management System uses the Global Positioning and Inertial Reference System consolidated position whenever the Global Navigation Satellite System information is available. During normal operations, ADIRS 1 and ADIRS 3 are supplied by Multi-Mode Receiver 1, and ADIRS 2 is supplied by Multi-Mode Receiver 2. If one multi-mode receiver fails, the remaining receiver automatically supplies all ADIRS. The Flight Management System computes a position based on all of the available inertial reference sources and the available radio nav aids. This position, which includes the inertial reference data, is referred to as the inertial reference radio position. Each ADIRS computes a position based only on its inertial reference source, referred to as the inertial reference position. Each ADIRS continuously computes the estimated position uncertainty, EPU, that is related to the computed aircraft position. The estimated position uncertainty is computed by its individual ADIRS. The estimated position uncertainty value corresponds, in nautical miles, to the radius of the circle around the computed aircraft position within which the real aircraft position is located during 95% of the time. The Flight Management System uses the required navigation performance (R&P) value together with the estimated position uncertainty value to define the navigation accuracy. Required navigation performance refers to the level of performance stated in nautical miles required for a specific procedure or a specific block of airspace. The Flight Management System uses a default required navigation performance value. A terminal area procedure may have an associated specific required navigation performance value defined in the navigation database. The flight crew can manually overwrite the flight management system default or terminal area procedure value. The flight management system continuously compares the current estimated position uncertainty from the ADIRS with the current required navigation performance and defines the navigation accuracy as high if the estimated position uncertainty is less than or equal to the required navigation performance, or low if the estimated position uncertainty is more than the required navigation performance. The aircraft is in navigation primary mode when the two following conditions are satisfied. The navigation mode is Inertial Reference System Global Navigation Satellite System, and the navigation accuracy is high. Note that when the navigation status is navigation primary, the navigation accuracy does not appear. If at least one of the two above-listed conditions is no longer satisfied, the aircraft is no longer in navigation primary mode, and the navigation primary lost message displays on the MFD and the ND. The MFD position monitor page displays the required navigation performance, the estimated position uncertainty, and the navigation primary status. The PFDs display the backup speed indication or backup altitude indication from the Full Authority Digital Engine Control FADEC computers and angle of attack probes when the automatic monitoring of air data by the PRIMs and ADIRS rejects the 3 air data references and the integrated standby instrument system air data. Or, the flight crew detects an unreliable air data indication and manually selects the display of the backup speed and backup altitude indications. In this lesson, we will discuss the radio navigation and standby instruments. The radio navigation system provides the flight crew and the other aircraft systems with navigation information. The radio navigation system includes the following systems: a dual VOR system as installed, a dual DME system as installed, and one marker beacon system. During normal operation, each flight management system can tune one landing system: the Instrument Landing System, ILS, the GBAS Landing System, GLS, or the Satellite Landing System, SLS. The standby instruments include one Integrated Standby Instrument System, ISIS, and one standby compass. In addition to the PFD and ND, the Integrated Standby Instrument System is used as Standby Flight Display, SFD. The Integrated Standby Instrument System provides an independent source of information for air data and inertial reference parameters, including altitude, attitude, and airspeed, and navigation information. The ISIS is connected to one standby pitot probe and 2 standby static probes. The Integrated Standby Instrument System includes internal gyrometers and accelerometers that compute and display aircraft attitude. Pressing the Integrated Standby Instrument System Landing System Direct to Push button displays the following landing system approach indications on the standby flight display: a localizer scale and index, a glide slope scale and index, a landing system course, a landing system source, and a landing system ident. Caution: do not use the Integrated Standby Instrument System Landing System push button for a back course takeoff or a back course localizer, as back course deviations are in the opposite direction. The following selections are available to be displayed on the standby flight display when the menu push button is pressed. Speedbug 1 and Speedbug 2 to set the speedbugs. Set altimeter bug to set the altimeter bug. Display meters to view altitude in meters, in addition to the altitude in feet. Set barometric unit to change the barometric pressure from hectopascal to inches of mercury. Display navigation to display the aircraft position, heading, and track. Display fix to modify and display a fix and maintenance, which is displayed on the ground only, and used for maintenance purposes only. Additionally, the menu push button enables an integrated standby instrument system reset in some cases.